Hello friends, today I am solving this problem, delete nodes in written forest. In this question what is happening, we are given one binary tree like this, and we are also given a list of the integer values, an array basically given. For example, see here, this is to delete. Okay, so these values are given to us and we have to delete these nodes whatever are mentioned in this. So if we delete those nodes, there would be a forest, right? Forest means different sub trees would be there, right? So we have to return a list of all those sub trees after removing these things. So let me explain this in a proper way with help of the same diagram. So see here, we have to delete 3 and 5 from this binary tree. So what will happen when we're gonna delete it? First of all, we have to delete this guy. Okay, so if we delete this guy, what will happen? This would be like we remove it. If we remove this, there would be two sub trees, right? So let's say if I am removing this guy, then see these are two sub tree here. Okay, so these also should be there in the list. So 6 is another subtree, 7 is another subtree in the forest. Now 5 is also we have to delete. So see here, when we are reaching here, we have to delete this guy 5, right? So if we delete this 5 also, this will become like this. So we have two trees here. See 1 2 3 4, one tree is there, and two trees are there, 6 and 7. So this forest, the list of these guys we have to basically return. Okay, so this is one tree, and one this, 2 and 3, total 3 trees. So basically we have to return the head of these sub trees. This is the forest which we will find. So this is what we have to do. Now we will discuss how to solve this problem. So guys, for the same example, I have just written the code here. Okay, this is very simple, straightforward code. So what is happening? So for example, if we are passing root equal to null, let's say if our root itself is null, then obviously we have to return null. Nothing is possible, right? Otherwise, see what we are doing here is we are writing this method in such a way that we have created one set, right, where we have to put all those values that we have to delete. We have to put first of all to that set, because we have to search whether something exists or not. So let's say we are using one set. This set would be having all the to delete values. Okay, so this set having all the to delete values, and then we have one answer list. Okay, that answer list basically having of the tree node type. Let's say this is our list. Okay, so now what is happening, we have to see, first of all we have to check if root is null, then we will return null, no pointer. Okay, now see here what we are doing. Otherwise this method is written in such a way that we are updating if something is there in the list that we are deleting, and updating this tree, and also returning the head of that. Okay, so we will do dry runs. This will make a better sense. So for now you can understand that here, see, we are again calling util for the left child. For example, 1 is not there in the list, that means 1 would be stay there, right? And then we have to modify on left and right side that what all things would be deleted now, because there could be a possibility from left side and right side that there must be certain things which we have to delete, right, or not delete. So for that reason, this function, what it is doing, it is returning after deleting whatever required. Okay, so that is why we are calling on left child as well as right child. Now see here, come to this point. If let's say root itself is there in this set, okay, to delete set. Okay, so if root itself there, that means this root will not exist at all in our answer, correct? So in this case what we will do, we will check whether we at this point we calculated the left and right subtrees, okay, which were modified and returned. So we will check if left side is whatever we return here, if it is not null, then we can add that value, okay, into the answer list. Similarly, if right child is also not null, then also we can add, because whatever is below it we already would have been updated. Okay, and then we are returning here finally return null, because our root itself is there in the set. If root itself is gonna delete it, that means we have to return the null. Okay, so if this is not the case, if we are not going inside this root.val, okay, this if condition, then anyway we have to return the root. Okay, so let's do the dry run so that everything would be very clear. So here in the set we had 3 and 5, right? 3 and 5 we have to delete. Okay, so see here we are coming to the root. So root is not null, right? So if root is not null, then we are going to inside here. Okay, so see here root dot left. Okay, so let's say root dot left, we are here. Okay, so we are calling directly on this left and right subtree, right? We are calling this util function. So see here, this is a bottom up approach. Now we reached here at 2, right, and at 3, correct, because call is happening now for left and right child. Now immediately in these call also, they will also call subsequently on their left child and right child, correct? We are also calling left and right, correct? So now the call shifted directly to these nodes, right? This is at 4, this is at 5, this is at 6 and the 7, correct? So now see here, after reaching here the call is happening again, but see when this call is happening again, now again see here, these guys are still not null, right? So we are not going inside this condition. Now their root dot left and root dot right is null, so it will returning these guys would be written as null and null, right? So now come here, okay, at 4 and 5, at 4 I am doing, okay, so similarly would be for all of them. So see here, hs contains root dot val. Is it true? No, 4 is not there, it is 3 and 5, right? This is 3 and 5, so 4 is not there, so we are not going inside it. So what will happen? We are at here, so return root. So basically here root would be returned, which is 4. Okay, so now what will happen for left side? So come to this call which we made at 2. So for 2, the left side it is coming 4. Okay, so we have got 4 here. Now come to this subtree. Okay, at 5 when the call happened, it is not null. It is left child and right child of this 5 is obviously null. So now we are checking this if condition. So hs contains root dot val. Yes, it contains root dot val. So we are inside this condition. So see here, if root dot left is not equal to null, because its root dot left is null, so we are not going to this if condition. Similarly right also null. Look at this guy, it has null left and right, so we will returning here null. So see here what it would be, this would be null. Okay, so our call till 2 is done. Okay, now look at this call. Okay, we were also calling at very first time, we called this function at 1, right? So from 1 it is returning 2, right? Because we are done with the ton, all the things. So come here at 2. Okay, so left and right child are already done here, correct? And come to here, this thing 2 is not there. 2 is not there in this set. So we are not going if condition. So anyway we are returning root, which is 2 in this case. So from left child of 1 we are returning this guy 2, which is also modified as a tree. Whatever its left and right would have been updated, we are done, and 2 is coming from its left side, correct? Now we will go to the right side of 1 because we are making a bottom up approach. So come here, we would be coming to 3, then come to 6. So from 6 what it would be written? From 6 it is doesn't contains at set, right? So from 6 left side of 3 it would be 6 only, like this. And from 7 this guy is also not available in this way, right? So this guy is also not available. So what will happen here? So 7 also would be returned from it. Okay, like this. Now because come to this guy, so when call happening here, so come to here, when the 3 call at 3 would be happening, then we are going actually in this if condition, right? Because 3 is contains, so set contains 3. So see here, root dot left of this guy is 6, correct? So we are adding this value into the answer. So see here in the answer so far what it would be, one is the this head, so 2 is already there because it was not null from the left side. Okay, so we are coming to that point. So see here, 3 is not at all there. So when we break this 3, 6 and 7 would be definitely go to the this thing. So these are basically the head node, but for the sake of simplicity, I'm denoting it with the numbers. Okay, so 6 and 7 has to go because see, root dot left is not null. So we are adding this into answer. So 6 would be added. Similarly, right is also not null. So 7 would be also added. So far 6 and 7 is added. And because we are here, so here return would be null. So from left side at this guy, what it would be returning to upper guy? It would be returning null. Correct? So now finally come here. So from 1, the left side was coming 2. So this guy would be like this. And from right side, it is coming null. Okay. So we will, let me remove this thing because it is returning us null. So now we have null at this side. So now come to here at 1. So when one call at 1 was made, see here, we will go to this if condition. If hs dot contains root dot val, no, 1 is not there. Correct? 1 is not there. That means we are coming here, return root. So return root. So 1 would be returned here. Now one thing I will tell you, this thing we are calling on left subtree and right subtree. Okay, so this utility function we would be using in our final answer. This is not the one which we are only using. I will tell you how to utilize this util function. Okay, so let me put that as well. So see here, that same util function what we are doing, we are calling this util function on the root. Okay, now we are parking the whatever value it is returning in the res. Okay, because left side and right side when it was called, it already updated and returned the right value. So see here, if res was null, then there is no point of adding it, right? So that is why if it is not null, then we are adding it into the final answer. Otherwise, we are returning this list, basically the answer list. Okay, so in this way we can utilize this util function. We just cannot directly returning whatever util is giving us, but we are returning whatever on the root it gives. If it is not null, then we will add it to the rest. Otherwise, we don't have to add. Okay, only whatever answer is given, that we have to return. So this is as simple as that. This is a bottom-up approach. So let me show you the corresponding code. It is same whatever I have just show you. So guys, this is our very simple code. This is our util, same util whatever I just said. So here I have global variable of has set and or list of answers. Okay, so see here, root is equal to null, then I'm returning null. Otherwise we are on calling it to root dot left and right, and this util function on left and right side, it would have been updated. So this is a bottom up approach. See here, we are checking if hs dot contains root dot val. So this list has the root dot val as well. That means if left side and right side, okay, if they are giving us non-null values, then we would adding them to the answer list, and we are returning null here because this contains the root dot val. Otherwise we are returning root. Okay, and similarly you can consider that inside util also these things would be repeated everywhere, and finally it would be returning whatever is updated and whatever subtree is there. So see here, I am just using it. First I am adding all the things to has set, whatever there into delete. Now see here, res equal to util root. So if res is not null, then only we are adding that as well to the answer list. And finally we are returning. So let me execute this. So I am running my code. Yeah, so it is working fine for this example. Let me submit it. Yeah, so it is submitted 97.28%. So thank you for watching the video, and if you guys have any concern, please make a comment over there. Thank you.